Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. In this video, I just want us to discuss the inverse of a function and continue with laying the foundation so that you can appreciate what we mean by the inverse of a function. So let me dive straight into the lesson. We did a similar lesson previously where I was showing you how to calculate the inverse. So let us start by saying, suppose you are given, for example, y is equal to 2x plus 1. Actually, let's call it f of x. F of x. We are given f of x is equal to 2x plus 1, and you should remember this is a linear graph or a straight line graph, which is y is equal to mx plus c. So suppose I'm given that, and then I need to sketch this graph. That's the part. I want to sketch this. Now, if I want to come up with an inverse of the graph, remember the inverse will be f of x equal to, now how do you do the inverse? Remember, as I said, when you're calculating the inverse, you go down and say let f of x be equal to y is 2x plus 1. So you convert that to become 2x plus 1. Then you move on to say interchange. What is x becomes y, what is y becomes x. So x is equal to 2y plus 1. You can grab hold of the previous video. It will help you in calculating the inverse. So from here, you make y the subject of the formula, take 1 to the other side. You have got x minus 1 is equal to 2y. The next thing is to divide by 2, divide by 2. This is fine to write it like this, but it will be difficult sometimes to sketch it. Alright, this is the inverse now. Now, when you are writing it, you can actually separate the 2 so that it becomes x is equal to this, y is equal to, you can write it like this, y is equal to x over 2 minus 1 over 2. That is the x minus 1 over 2. Or you can even write it like this, 1 over 2 x, this is x over 2 minus 1 over 2. So this becomes the inverse of this graph. Now remember, the aim is to sketch the graph and its inverse so that you can appreciate. That's what I want you to do. I want you to appreciate this part of what is an inverse, and when we sketch that, you're going to just take note of a few things which are always characterized by inverses. So look at this. If I'm to draw this graph, and I can come up with a table of values here. Remember, when you're drawing the graph, you need to it's easier if you come up with a table of values. I'm going to do it because I want you to appreciate this part of the inverse. So I'm just going to quickly draw a few points here, as well as even here I'm going to draw a few points. Okay, and then you're going to kind of have an idea why I did what I did. So let's say we want to sketch this graph and we want to have a table of values like that. Alright, so look at this. If I start with the first one, this is my x, this is my f of x. Alright, so now when x, let's start from minus, for example, minus 5, minus 4, this is too far. Let's say minus 3, minus 2, minus 1. Okay, yes, minus 3, minus 2, minus 1, 0, 1, 2, 3. This will work. So if it's minus 3 here, you can put a calculator. Minus 3 becomes minus 5, minus 2 here becomes minus 3, minus 1 becomes minus 1, 0 becomes 1, 1 here becomes 3, so you're jumping 2, 2 becomes 5, 5 becomes 7. So these are the points that you have, and we're going to plot that. What about same way if we now plot this graph of x and the inverse now? So we're starting from minus 3, let me just say minus 4 in this case, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. And then let me just use the calculator in this case to say 1 over 2, and then let's start with minus 5. I want you to see minus 5 minus 1 over 2. So right, the first one is minus 3. You put 4 here. I mean negative 4 is minus it was minus 3. Now this is minus 2.5. You put 3 here. Negative 3 is minus 2. So it was minus 3 minus 2.5, and then minus 2, and then it continues. Also guys, just in the background, if you hear some noise, apologies, is my load shedding here, and there is some background noise from the generators that are running, so apologies that, but I just had to bring this to you guys. And then if it's minus 2, let me just bring again the calculator and say if this is minus 2, so I've got 1 over 2, x is what? Negative 2, and then minus a half. I shouldn't have taken it out, so it's minus 1.5. I put minus 1 here. Minus 1 is minus 1. I put 0 is half. Let me put 1 here. If I put 1, not 11 but 1. If I put 1, 1 becomes 0, and then if I put 2 here, becomes half. If I put 3 here, becomes what? 1. So you can see 3 is 1, this is a half. If I put 1, it was a 0. If I put 0, it's negative half. If I put minus 1 here, it was negative 1. If I put negative 2 here, a negative 2, so it was negative 1,5. So this is what we are having, and I need to sketch this. Now if I can bring in now my graph paper kind of a thing. Look at this. I just want to plot this graph. Let's do it now. I just want to plot, let me make a big line. I just want to plot a graph like this. These are my x's, okay? Let me just take it a little bit down. Alright. So these are my x's. Remember, this becomes my y. This becomes my what? My x. So this is my y-axis. This is my x-axis. So I want to plot this graph of inverse as well as what? As well as the original graph. So let's do this to say in here I'm given, these are the points I have to mark. Alright, as I said guys, the aim is to what? Is to appreciate this graph. I just want you to appreciate what I'm doing. Whenever you're dealing with an inverse, you just have to appreciate a few things and then use those as your background to answer some questions. Remember, positive 1, 2, 3, 4, 5, 6, and then this is minus 1, minus 2, minus 3, minus 4. This is 1, 2, 3, 4, 5. Minus 1, minus 1, minus 2, minus 3, minus 4, minus 5. So let's start with the first graph. If I'm saying minus 3 is minus 5, so x is minus 3, y is minus 5. It's here. So I'm gonna mark it minus 3, minus 5. Let's start marking that. There is a point there. Then the next one is what? It's negative 2, negative 3. There is a point here, negative 2, negative 3. And then continue. Negative 1 is negative 1. It's here. And then when x is 0, y is 1. I've got a point there. When x is 1, y is 3, I've got a point there. When x is 2, y is 5. And then when x is 3, y is 7. I don't have that, so let's limit it. Let's limit it there. And let me draw a line here. And you can see this line is that. It can stretch further if you want it. It can stretch further like this. Whatever, but it's fine like that. So this is the line you're having, and don't forget this graph is what? The graph of f. Now I want to sketch the other graph. The other graph is the inverse. So let's do it. When x is minus 5, minus 5 is minus 3. Minus 5, minus 3, I'm gonna use something different. Minus 5, minus 3, there is the point there. And then what do we have? We've got minus 4 and negative 2.5. So I've got minus 4 and negative 2.5, maybe somewhere there. But we can leave that one. Minus 3 minus 2 is straight away. Minus 3 minus 2 is a straight point. And then what we have, we can leave this one of 1,5. There is 1, minus 1, minus 1. There is a point there I can take. It's a point of intersection there. I can leave this one 0.5, 1, 0. When x is 1, y is 0, I can take that one. Leave 2.5, 3 and 1, I can take that one. Because it's just on the whole number part. Now look at this. If I'm to draw this graph also, I'm going to have something like this, joining these points. See that? And then if I can go backwards to be exactly like that, yes, like that. Now this is the graph. Remember, this graph is the inverse of the graph. Now I'm going to draw a special line, and that line I'm going to draw is this graph. Draw the graph of y is equal to x. Now since it's y is equal to x, it's easy to come up with points. I can come up with just 2 points here, x and y. X and y. Remember, y is equal to x. If x is, for example, minus 5, y is minus 5. If x is 4, y is 4. So I can join those 2 points. So let me start with x is minus 5, y being minus 5. There is a point there. If you say minus 4, y will still be minus 4, you know. When x is 4, y is 4. Just x is equal to y. So you'll be repeating that. So if I can draw this line, it's a very special line. And then like this, that's better. Now look, this point is, this graph is called y is equal to x. Very important. Just remember, it is a very important line. But now, look at this. I just want to show you something interesting about these 2 points. I just want to show you something interesting about these graphs. To say, if you start comparing them and asking yourself what happened. For example, let me flag out this point. You will start to notice something here. To say, look at it. It was when x was equal to 3, y was equal to negative 3, y was equal to negative 5. But now, if I say this is the graph of what? Of f, but at the same time, if I say let's go to x is equal to and y is equal to, if I say let's go to x is equal to minus 5, right? And y is negative 3. Look what I did. I just interchanged here. Where there was this, I interchanged. See this? So now look, let's go to those 2 points. Let's go to minus 3 and minus 5. When x is minus 3 and minus 5, I'm going to use the white. Minus 3 and minus 5 is here. There is the point. Minus 3 and minus 5, right? It's in the yellow. But I said interchange and draw minus 5 minus 3. Minus 5 minus 3. Look at this. I think that these points take note again. These points take note. Take note of these points. Take note of these points. Oh, my line here actually was not straight off this one. It went off. I thought it was straight here. It was supposed to be a line that was going like this. Where is this? Supposed to be a line like this. Much better. But let me make it bigger. It was supposed to be a line, not like this. Like this. This was the line I wanted. Alright, so now let's do it again. Here, look at these points and take note of these points. Alright, now let's choose another point. If, for example, I need whole numbers, -2 and -3, if you interchange, look at this. If x is equal to -2, y is equal to -3, if I interchange these, what will I have? I'll have x is equal to -3, y is equal to -2. Let's look at this. Let's go to -2 -3, the first one. When x is -2, y is -3. There is a point there. And the other one is -3 -2. There is a point there. And then again I say, take note of that. Take note of this. Take note of that. Now, let's look at another whole number, 2 and 5. When x is 2, for example, this one. Now you can see what I'm doing. When x is 2, y is 5. Let's identify that point. When x is 2, y is equal to 5. There is that point there. And the inverse of it, or the other point of it, will be when x is 5, y is 2. When x is 5, y is 2. That point is supposed to be there. You see, but we can test it to say, if I can put here when x is 5, let's see what it's going to give me with the calculator on this one. So it will be 1/2. X is what? Is 5 minus 1/2. What is it giving me? It's giving me a 2, you see? I can predict it now. So which means, again, take note of these points. Take note of that. So what is happening here? You can see that when I'm talking about an inverse, I'm actually interchanging here. This was f and x. So if I'm talking about an inverse, if I give you x and I give you y, in the inverse you interchange. This one becomes that, that one becomes that. That's what is happening. And then there is a special line. This line y is equal to x. We call this line the reflection line. To a point that if I bring this like this, without showing you now, you can see that this line is the mirror. Okay, that y is equal to x is the mirror line. What it does is it reflects f along the line y is equal to x so that it becomes the inverse. But in that reflection, the inverse, I think we've seen what is happening. If I give you a point, for example, I give you a point 1, 3. If I say to you, x on the original is equal to 1, y is equal to 3. And then I say, what is the inverse of those points? Then you're going to say x is equal to 3, y is equal to 1. What did you do? Take this up, take this down. Then you get these points. And then if you say 3, 1, you come here. You see, there is that point. And then what was 1, 3? When x is 1, y is 3. There is the point. Do you see how the inverse it does? What the inverse does in a way, it reflects. Are you with me? So that's what you're actually doing. You're just reflecting points x, y becoming y, x. And then you are reflecting them along the line y is equal to x. Don't forget that. So, which means without this, without this, I can actually draw the graph. What I just do is I come to this graph as my normal graph here, and then interchange it and interchange it. I will come with the graph, this one, without having to draw the other graph. Do you understand? Now, if this is so, how about now we come back to what they usually ask you in an exam. Let me think of what they usually ask you. They usually ask you to say, for example, you are required to draw this graph. For example, y is equal to 2 to the exponent x. This is what usually they ask you in an exam. Y is equal to 2 to the exponent x, and they want you to sketch this graph. So if you had to sketch this graph, before that, look at it, a few things. When you are sketching this graph, first of all, you need to know that this is an exponential graph. Exponential graph, right? And then if it's an exponential graph, what it does is it has got an asymptote, and then with that particular asymptote, we're going to discover it. How does it this graph goes? If I'm to sketch it, just want to show you a few things when they say sketch that graph. Without saying much, this is how this graph looks like. So you'll have here your x, you'll have here your y, and then you'll draw a graph like this. If they just say sketch this graph, this is how this graph looks like. It looks like this. It's an exponential graph. Alright, and then usually they will ask you this point to say, what is that point? Now, it's a very important point that you need to know. That particular point is, we are saying when x is 0, y is what? Y is 1. Remember, when x is equal to 0 here, if I can calculate it now, when x is equal to 0, what do you have? Y is equal to 2 to the power of 0. Any number to the power of 0 is equal to 1. So that point is always 0 and 1 when you're dealing with the exponents. Alright, now if I were to draw now, okay, before that, then this line here, the asymptote line, will be the x-axis. These lines, they become what is called the what? The asymptote. Are you with me? But I can change it and say, what about if I were to draw a graph of let's change the graph here to say, make it like this, y with another one. Let's change this, make it like this. So y is equal to 2 to the exponent x, and then you say plus 1. So now what you do is, that particular one now is the new asymptote. You must know. So which means what you do now, this graph, you come here along this horizontal line here. Remember that point that was 1. Let's draw it a little bit. Yes, this point that was 1. So this line y, because it cuts at y-axis, is equal to 1, is the asymptote. And then when you are drawing this graph, you have to sketch it. It will similarly look the same, but this is what it does. Look at the new graph. The new graph is like this now. Okay, let me do much better than that. This is the new graph, and then you have a new point there. Now the point is what? Remember, at that point we are saying here, when x is equal to 0, here when x is equal to 0, so you put a 0 there, so y is equal to 2 to the power 0 plus 1 now, which is 2. That's why that point now moves one step up because of this plus 1. And then you've got here 2 and 0 and 2. I hope you can see how you draw this asymptotes, right? But that is not only that. I'm interested now in the inverse. So when they say draw an inverse of this graph, I told you this, for example, let's start with this one that I'm circling red here. Let's start with this one. When you're drawing an inverse, look at it. If y was equal to 2 to the power of x, or let's call it f of x. If f of x was equal to 2 to the exponent x, what about the inverse of x? Before we calculate it, how will you sketch that graph? We're going to calculate it, but look, now we had a point here 0 1, and I told you when you're doing the inverse you interchange, it will become 1 0. So I'm going to look for a point here that will represent my 1 0. This point is 1. Remember, this is the x and that is the y. So when I'm sketching that point, and then I must remind myself there is a line, but that is called y is equal to x. Remember the one I told you about? We call that line the line of reflection. It is what? Y is equal to x. You sketch it like that. Very important line. So this, you call it y is equal to x. So when you are sketching that part, you have to call this mirror line, and when you are sketching it, you are going to have a graph similar, but now look at how you interchange. If the x-axis were the asymptote, remember here we called the x-axis the asymptote. Now the y-axis becomes the what? The asymptote. You interchange the x before, the y before. So how will the graph appear? The graph will appear just similar, but now changing to become like this. Look at it. That is the graph. It will continue and continue, and this graph now is the inverse. Right, now if it was the one which we called it draw the graph of y is equal to 2x plus 1, this one, let me write it again. We called it y is equal to 2 to the exponent x plus 1. Now if I'm to draw the inverse of this second one, look at what happens. Doesn't change. Y is equal to x is always the what? The line of symmetry. Now because it's plus 1, look at this now. My asymptote, we come here and say there is a new asymptote here. Since this was the asymptote, where did I write? This was the asymptote of the new graph. So here you draw also a line that is the asymptote that cuts it what? That cuts it 1. You see how this thing goes about. It will be like that. There is an asymptote. Let me move it somewhere here. So there is this asymptote, and when you're drawing the graph similarly from this previous graph, but now it does this. Are you with me? Now where does it cut here? You interchange. It was 0 2, so this becomes what? Interchange. It becomes 2 and 0. Are you seeing what's happening? So that's what you are dealing with when you're dealing with inverses. It's a matter of you changing. What was x becomes y. What was y becomes what? It becomes x. So basically when you're dealing with inverses, guys, don't forget, that's how you do that. But as we said, what is this graph? This one. Or what is this graph? This graph, for example, when you're changing to inverse, remember what we said, you interchange. You start from saying let f of x become y, so it will be y is 2 to the exponent x, and then you interchange x is equal to 2 to the exponent y. Now from here, how do you make y the subject of the formula? That's why we said y is equal to log base number. Y is equal to log base number, which is equal to y is equal to log. Now 2 is the base, and the number is what? It's x. So here you are plotting the graph of y. This is y is equal to log in base 2 of x. But what about the other one? Not this one, actually. It's not this one, it's the other one. This one. Let me put it. Yeah, it's fine like that, but it's this one. This is this graph. What about this one? It was y is equal to 2 to the exponent x plus 1. You interchange again. X is equal to 2 to the exponent y plus 1, and then when you're interchanging, take this one to the other side. You've got x minus 1 is equal to 2 to the power y. Back again to say, now be careful, put this in brackets, and then you're going to say y is equal to log base number. So y is equal to log, that 2 is the base and the number is that, which is bracket x minus 1. Are you getting that? So this graph, this one, is equal to log base 2x minus 1. So don't forget, it does not, it always, the reflection line is the one that is, you must be interested in, y is equal to x. So just work on that. Ask yourself, what is the reflection line? Alright, so with that, guys, let us look at this question to say, here, this is one question to say, consider the function f where f of x is that. Write down the domain and range of f. Now remember, domain means what? Domain means x, range means y. So of f, now what is the domain? Here, the x values. You can see that this is a straight line graph. So you can say x is an element of what? Of real numbers, any real number that you can think of. And y is an element of what? Of real numbers. Because the domain and range, any number, we will draw the graph. And then show that f is a 1-to-1 relation. When they're saying 1-to-1 relation, we're saying one value of x will give one value of y. So how do you show that f is a, for example, choose any value to say, suppose let x be equal to 1. So f of 1 is equal to 3, 1 minus 1, which is equal to what? 2. So you're saying when x is equal to 1, f of x is equal to 2. Therefore, by doing that any value, we are showing that it is a 1-to-1 what? It is a 1-to-1 function. Alright, and then the x1, determine the inverse. Think you know what to do. You said f of x is equal to 3x minus 1. Change that to y is equal to 3x minus 1. Then make you interchange. X is equal to 3y minus 1. And then when you've done that, what do you do next? You make y the subject. There becomes x plus 1 is 3y. You divide by 3 on both sides. There is the inverse. Y is equal to, remember 3, it will be x over 3 plus 1 over 3. That's the inverse. So you can put that, but it's better this is that is equal to 1 over 3 x plus 1 over 3. That becomes what? The inverse. And then sketch the graph of the functions f and the inverse and the y-inverse on the same set of x's. Now because of my time, I'm not going to sketch this. Now I want you to sketch these graphs. You sketch this graph, alright, and then you come and sketch this graph. But I told you, once you sketch this one, you don't have to actually sketch this. You sketch this and you interchange the values. For example, if you do this and say these were my x values here, to say x and then f of x, then you say, for example, 0, let's start from negative, because you need negative 3, maybe negative 2, negative 1, 0. For example, when x is 0, y is negative 1. On the other graph, you just interchange. On the inverse, say x inverse. Where it is 0 here, you say negative 1, 0. Are you seeing that? And then you say minus 1. If it's minus 1, it's minus 4. You will have minus 4 minus 1. You just interchange. And then you sketch the graph. And the graph of y is equal to x. And remember, this graph is the reflection line. Alright. But now, what I'm going to do in the next lesson, I'm going to bring now a typical exam papers that they usually ask when it comes to inverse. Now, you'll join me now in the next lesson where I'll be now attacking previous papers to say what do you expect in an exam, so that you don't get caught up or taken by surprise. So guys, we've come to the end of our lesson. Remember, it is good for you to be subscribed so that you can follow up every time we post a new video. Thank you.